So if a number divided by 0 gives us an infinity, what about some other mathematically tricky cases, such as 0 divided by 0? What should that be? Well, 0 divides 0 is completely undefined. There's actually nothing that we can really say about that. And so we have another special case in floating point, this NaN. That stands for not a number. So basically, it's the mathematical system inside the computer is throwing up its hands and saying, yeah, well, nothing much I can do about that. Sorry, that is completely undefined. And so this arises when you have a handful of special cases that don't really make sense. So 0 times infinity, for example, infinity divided by infinity, for example, and probably a few others as well. And so you get this result NaN. You can also get that in MATLAB just by typing out NaN. You can test for it using this isNaN function. That will tell you whether or not this number is NaN. Now, I want to show you an interesting property of this NaN result because it might affect the way that you write your code. So here I have an example, a silly little program that does a few calculations and then runs a particular test. And so let's have a look at the top here. I'm just going to put in a little message so that we can see that our program is running. We'll clear the screen, print the message, and we do some calculations. So we get numbers x and y, which I have started here with 2 and 3. We do some calculations. So we take the exponential of this one, we take the exponential of the other one. I'll divide them, and then I want to see, is the answer positive? Now I put it to you that this answer will always be positive, provided that these are real numbers. Let's actually run through and see why that should be the case. So I'll assume that these are reals, x and y here. So assume real and assume real. So the exponential of a real number is necessarily positive. If you look at the graph of e to the x, you can see that that is the case. So this one must be positive. Finally, b here also must be positive by the same argument. This is the ratio of two positive numbers, so it must be positive. And that means that this here actually must be true. In fact, if I go greater than or equal to, we'll be definitely confident that that is true. This will indeed always be a positive number. And in fact, I can run this program, and yes, indeed, I see this message is printed. So now I'm going to start pushing the boundaries a bit. And so I'm going to start making these numbers larger. Let me run it one more time. And whoa, we have a problem. So what's actually going on here is that we had, let's have a look at our workspace. And value A was evaluated to infinity. We had an overflow here. Same thing happened for B. We had an infinity. This was the exponential of a very large number, and that was not able to be computed. Then we took the ratio of them in this line here. So we had infinity divided by infinity. Now that is undefined. That is not a number. Then we got to this test. And it turns out, and this is quite important, so I'm going to make a little note here. It turns out that any test involving NaN returns false, always, every time. Every comparison that you do with not a number will always return false. And so that means that if you're not careful in your calculations and you somehow end up generating NaN values, then you have to be really careful that you don't get issues with comparisons returning values that you didn't expect. And so how would you avoid that problem? Well, I mean, this is kind of a silly example, but maybe we could say, or is this not a number in this scenario if I really did want this condition to always evaluate? Maybe there would be some other case here, more realistic, else if is not a number, and then I would say here that something went wrong in the calculation. So at least I'm now able to handle that scenario. Let me run this program, and we see indeed this message gets printed to tell us that actually we somehow produced an NaN value in our calculation. Another property of NaN is that it is sticky. So if NaN gets involved in a calculation, it will stay there. And so if you have whatever expression, if any single one of those terms is an NaN, then the answer will also be that same NaN. So it will carry through your calculation, basically, and your final answer is going to come out to be this, even though the original problem might have occurred quite some time ago in your code. So that's something else that you need to be aware of and keep an eye out for when you are doing calculations based on floating point numbers.